Welcome. Let's understand breaker and a half scheme, or 1.5 cb scheme.
In this scheme, 3 circuit breakers are used for controlling 2 circuits as shown in figure. Each line is protected by 1.5 circuit breakers, hence this scheme is known as 1.5 breaker scheme. An outage of any bus or any breaker does not outage any lines. Normally, both the bus bars are in service. This scheme have more operating flexibility than mesh bus. Requires 3 breakers for every 2 circuits. Widely used at high voltage, especially where multiple circuits exist, e.g. generating plants. A fault on any bus is cleared by the opening of the associated circuit breakers, without affecting continuity for supply. Similarly, any circuit breaker can be taken out for maintenance without causing interruption. All load transfer is done by the breakers and therefore, the operation is simple. However, relaying is somewhat more involved as the third breaker has to be responsive to troubles on either feeder in the correct sequence. Besides, each breaker has to be suitable for carrying the currents of 2 circuits to meet the requirements of various switching operations, which may in some cases increase the cost. The breaker and a half scheme is suitable for those substations, which handle large amounts of power on each circuit. The scheme has been widely used particularly for EHV substations. Here, main 1 CB is open and no interruption of power supply to feeders. Here, tie CB is open and no interruption of power supply to feeders. Here, main 2 CB is open and no interruption of power supply to feeders. In case of main 1 breaker is open, then power flow direction shall be as shown in sketch. During normal conditions, all the 3 circuit breakers are closed and both circuits operate in parallel and power is fed to feeders from the 2 bus bars. If the fault occurs on one bus bar, then with the help of the second bus bar feeder circuit breaker and tie breaker power are fed to feeders. This means each feeder breaker has to be rated to feed both feeders which are coupled by tie breaker. Here, in case of a bus 1 fault, associated bus 1 breaker will get tripped. Similarly, in case of a bus 2 fault, associated bus 2 breaker will get tripped. If a center breaker or tie breaker failed, this will cause the loss of 2 circuits, while the loss of an outside breaker would disrupt only one. If a main 1 or main 2 breaker failed, this will cause the loss of 1 circuit only. If plot area is rectangle, then you may go with I-type arrangement. And if plot area is square, then you may go with D-type arrangement. Thank you for your attention and time. More stuff coming soon. Don't forget to subscribe.